So now let's use these equations that we figured out, that we saw in the last video, to find important things regarding functions, derivatives, and points at which derivatives are evaluated at. So this right here, this equation is the derivative of a function at some point A. So this is a value. This should give you a value. And it's the derivative, it's the slope of a tangent line of some function, f of x, at some point A. So this is the derivative, f prime of x, at some point A. And we want to find out what is f of x, what is A, what is f prime of A. And let's also do what's f prime of x. So looking at this, well, we see we have an h, and we're dividing by an h. So out of the two formulas that we were using in the last video, we can say that it's most similar to this bottom one. So let's go ahead and write that down. What we're saying is that the derivative at some point A is equal to the limit as h approaches 0 of the function evaluated at a plus h minus the function evaluated at a all over h. So now we're going to kind of have to match up these terms. So obviously the dividing by h, you can see that here. These match up. And it seems like this term matches up with f of a plus h, and this term 4 matches up with f of a. So since f of a plus h seems to me matching up with 2 plus h squared, well, from that alone, we can tell that it seems like a is equal to 2. And since a is equal to 2, well, 4, in this case, this is equal to f of a. So f of 2 is equal to 4. And there are a couple different possibilities of how to get that. It could be 2 times 2, it can be 2 squared, 2 factorial times 2. There are lots of stuff that can give us this. So we're going to look back at this. F of a plus h equals 2 plus h squared. Well, if we kind of ignore the h's, we can say that f of a, is equal to 2 squared. So it seems like f of x is x squared. And that's how we get this 4. If we plug in 2, we get 4. So we're kind of looking at how these terms match up and seeing, well, what does f of a plus h look like, and then what does f of a look like, so what does that mean for f of x, and then we can figure out these. And f prime of x, we can use the power rule, and in the next video I'll go over in more detail how to use the power rule. The derivative of x squared is 2 times x. So now, what is this derivative? What is the slope of the tangent line to f of x, which is x squared, at some point A, in this case 2? Well, we can evaluate this. So this limit function is equal to the derivative of f of x at some point A, where A is equal to 2. So it's the derivative at the derivative of f at 2, which is equal to, well, f prime is just 2 times x, so 2 times 2, which is 4. So this derivative, this limit notation, which looks messy, turns out to be 4. So just to recap, we were just looking, trying to match up this equation with this equation, and from that figure out what a is, what f of a is, what f of x was, what f prime of x was, and using that we could figure out what this derivative turns out to be. So now let's look at another example. So we have the limit as x approaches 2 of x squared minus 4 all over x minus 2. So once again, looking back to the previous video, is it more similar to this or that? Well, we have the limit as x approaches something, and we have an x minus something here. So it seems like we're using this equation as opposed to that equation. So I'm just going to copy that equation down. So we're saying that the derivative, the slope of the tangent line at some point A is equal to the limit as x approaches A of f of x minus f of a all over x minus a. And to me personally, these types of questions are much easier, since right there and right then you can really see what each variable is. A is obviously, just looking at the denominator, we have an x minus 2 is equal to x minus a. If you solve that, you can see x is equal to a is equal to 2. F of x, also pretty clear to see, we have an f of x minus f of a. F of x is going to be this x squared. F of a is going to be 4. And what else do we want to look for? We want to find what f prime of x is. So as you can see, this is the same derivative as the last question. The last question that we did just looked different, but once again, a is the same, f of x is the same, f of a is the same, and therefore the derivative should be the same. You could also use the power rule to figure that out. And once again, if we wanted to evaluate this derivative, well, using the definition of the derivative, we know that this has to equal the derivative of f at some point a, which in this case is 2, which is equal to f prime of 2, 2 times 2 equals 4, which shouldn't surprise you since that's what we got on this question. So that's pretty cool that you can write the derivative in 2 different ways that look completely different, but they turn out to be the same. And in the next video, we'll actually look at the derivative as a function, instead of, in this case, where we looked at the derivative at some certain point.